Hello students, today we are going to start with chapter number 5, that is substances in the surroundings, their states and properties. Students, I have divided this chapter in two parts. In this video, we are going to learn first part of this chapter, which includes following topics. First one is change of state of substances. Second one, heat and change of physical state. Third one, the temperature and a thermometer. Fourth one, boiling. Fifth one, freezing. And last one, sublimation. So, let's start. You recall, name the solid, liquid, and gaseous state of water. So, students, ice is solid state, water is liquid state, and the vapor is gaseous state of water. There are three states of matter: solid, liquid, and gas. Let's try this. Take pieces of wax in a bowl and heat them on a candle or spirit lamp. How do the pieces of wax change? The physical state of pieces of wax changes from solid to liquid due to heating. What was the initial state of wax? The initial state of wax was solid. What did it get converted into? It get converted into liquid state. Now keep the same bowl in cold water. What happens? When we keep the same bowl in cold water, the state of wax again changes from liquid to solid. So students, change of state of substance can be defined as when a substance changes from one state to another. The process is called change of state of the substance. For example, melting of candle. In this, the candle is in solid state, and on heating, solid state gets converted into liquid state. Next example is melting of an ice cream. Here also, solid state gets converted into liquid state. Another example is freezing of coconut oil. Here, liquid state gets converted into solid state. Next example is boiling of water. Here, water is in liquid state. So, on boiling, liquid state changes into gaseous state. Students, read this list of substances. The substances are as follow: spirit, camphor, petrol, ghee, coconut oil, naphthalene balls, ammonium chloride. Ammonium chloride is also called as Navasagar. And answer the following questions. Which ones freeze in winter? In winter, the ghee and coconut oil will freeze. Which liquid have you seen change into a vapor? Spirit and petrol are changed into vapor. Which solid directly change into the gaseous state? The solid substances such as camphor, naphthalene balls, and ammonium chloride will directly change into the gaseous state. So, students, what do we learn from this? The state of a substance changes if it is heated or cooled. Every substance in our surroundings is found in either the solid, liquid, or gaseous state. Students, let us have some information about the great scientist. Josiah Willard Gibbs was born on 11th February 1839 and he died on 20th April 1903. Was an American scientist who made significant theoretical contribution to physics, chemistry, and mathematics. In the 19th century, the scientist J. Willard Gibbs showed that the characteristic properties of a substance depend on its physical state and the arrangement of particles in it. Now we will study the differences between the states of substances. First state of substances that we are going to study is solid. For example, let's take a piece of iron. iron is in solid state. If you observe piece of iron carefully, you will see that it has shape of its own. It retains shape no matter how it is kept. Solid substances has definite volume. Volume means the amount of space that a substance or object occupies. For example, solids like sugar and sand, when poured on a flat surface, they forms a heap. So students, solid substances has a shape of its own and has a definite volume. Second state of substance is liquid. Examples of liquids are water, spirit, and oil. So students, liquids does not have a shape of its own. It takes the shape of the container, but it has a specific volume and occupies definite portion of a container. Liquid sprayed on a flat surface on pouring. It flows downwards along a slope and takes the shape of the surface. So students, liquid substances does not have a shape of its own, but it has a specific volume. Third state of substance is gases. Example of gases is air. So students, can we see air? No, we cannot see air. It is present everywhere. Air does not have a shape of its own. It occupies all the available space on the earth, and also it does not have a definite volume. On changing the pressure on a gas in a closed container, its volume also changes. So students, air does not have a shape and also it does not have a definite volume. Next is heat and change of physical state. You have learnt that change in the physical state of a substance is an effect of the amount of heat in it. On gaining heat, the substance changes from solid to liquid and liquid to gas. On the other hand, when the substance cools or loses heat, it changes from gaseous to liquid and liquid to solid state. Can you tell, does water change into vapor the moment we place the vessel on a stove? Does water kept in fridge change at once into ice? No. It takes some time to change the state of water into vapor and water into ice. A specific amount of heat must be gained or lost before the state of a substance can change. The change in physical state is determined by how hot the substance becomes on gaining heat or how cold on losing it. How do we tell how hot or cold our substance is? We can tell about how hot or cold are the substance by measuring the substance temperature with a thermometer. Next is the temperature and a thermometer. When a substance gets heat, it becomes warm and then hot. We put our finger in the water to judge how hot it is. But that is not an accurate measure. Besides, if the substance is very hot, we could get scalded. When you get fever, your body temperature is high. To get accurate body temperature, we use thermometer. A thermometer is used to measure temperature. Degree Celsius is the unit of measuring temperature. There are several types of thermometers available. We can find different types of thermometer available in our day-to-day life, like digital thermometer, clinical thermometer, and many more. Nowadays, digital thermometers are frequently used thermometers. Now students, let us see working of thermometer or how temperature is recorded in thermometer. As we know that the thermometer consists of three main parts, namely bulb, capillary tube and scale. The bulb of a thermometer is filled with mercury. The mercury rises up to a certain level in the capillary tube above the bulb. Also, the scale is present just near to the mercury column. The temperature of a substance is determined by reading the figure near the mercury level. Let's try this. Take a thermometer from the laboratory. The bulb at its lower end is filled with mercury. The mercury rises to a certain level in the capillary tube above the bulb. You will see a scale next to the mercury column. Reading the figure near the level of the mercury tells us the temperature of air around the bulb of the thermometer. Hold the thermometer in water so that the bulb is completely immersed in the water and read the temperature of the water. Repeat the activity, taking some hot water in one vessel and cold water or ice in another. When you repeat the activity, taking some hot water and cold water, you will observe that both activities gives different temperature in thermometer. When the thermometer is in hot water, the temperature noted is more, and when the thermometer is in cold water, the temperature noted is low. Students, let us see some examples with their constant temperature. The temperature of boiling water is 100 degrees Celsius. Then the temperature of freezing water is 0 degrees Celsius. The temperature of air in the winter at night is less than 15 degrees Celsius, and the temperature of air in the summer season in afternoon is more than 35 degrees Celsius. Then the temperature inside the fridge is less than 5 degrees Celsius, and the temperature inside the freezer is less than minus 18 degrees Celsius. And the temperature of body, that is, we can say the temperature of human body is approximately 37 degrees Celsius. Now let's learn about boiling. Water is continuously evaporating. We know that water spilled on the floor dries up slowly on its own. This evaporation occurs from the surface of the water. Now, students, what happens when water boils? As the water gets heated, its temperature increases and it evaporates at a faster and faster rate. When water kept on a stove attains or reached at a particular temperature or level of heat, then evaporation takes place in all parts of the body of water. Then we see water bubbles rising at faster and faster rates to the surface and steam mixing in the air. This is called boiling of water or ebullition. At sea level, pure water boils at 100 degrees Celsius. This is the boiling point of water. So, students, boiling point of water is 100 degrees Celsius. When water vapor cools, it is converted into water again. This process, that is the conversion of water vapor into water again, is called condensation. Condensation of steam also takes place at 100 degrees Celsius. It means that the boiling point and condensation point of water are one and the same. So, students, here is an activity for you all to do. Take some water in a beaker and place a thermometer in it. Heat the beaker on a spirit lamp. Note the boiling point of water. Repeat the activity adding salt or sugar to the water and note the boiling point again. So, students, you have to perform this activity and find out the boiling point of water after adding salt or sugar. Is freezing. The water kept in a fridge or an ice becomes cooler and cooler. That is, its temperature falls. At a certain temperature, water does not get any cooler but starts freezing and form ice. The temperature at which this happens is called the freezing point of water. The temperature of a substance can fall below 0 degrees Celsius. Example, the temperature of air in the freezer of a refrigerator is around minus 18 degrees Celsius. It is read as minus 18 degrees Celsius. When ice gets heat, it starts melting or changing into the liquid state again. Ice melts at 0 degrees Celsius. It means that the freezing point and melting point of water are one and the same. Each substance has a specific boiling point, which is also its condensation point. Each substance has a specific melting point, which is the same as its freezing point. The temperature at which a substance boils while heating is the same as the temperature at which it condenses when it is cooled. Similarly, the temperature at which a substance freezes while cooling is the same as the temperature at which it melts when it is heated. Brain power. The chart given below on the screen shows the boiling point and freezing point of some substances. State whether these substances are solid, liquid, or gaseous at room temperature. Now, students, here all the substances given, that is candle, plastic, and iron, will remain in the solid state at room temperature. Next is various uses of changes in physical state. First one is candles are made by melting paraffin wax. Second one is solid carbon dioxide, which is also known as dry ice, is used to make ice cream and to keep it frozen. Third one is liquid nitrogen is used in animal husbandry. Fourth one, sand silica is melted to make glass. Fifth one, metals like gold and silver are melted to make ornaments. Sixth one is iron is melted to make tools. Next is sublimation. Let's try this. Take some sand in a crucible, put a few iodine crystals on it, place the crucible on a tripod to heat it, block the steam of the funnel with a cotton plug and place it inverted over the crucible, light the burner and heat the mixture in the crucible. Observe the changes. Why does this happen? Now, students, iodine crystals do not melt on heating but change directly to the gaseous state. When the fumes of iodine hit the walls of the funnel, they cool to form solid crystals of iodine and stick to the funnel walls. Thus, on heating, iodine crystals does not melt and change to a liquid but directly changes to the gaseous state. The change of a solid substance directly into a gas or vapor without first changing into a liquid is called sublimation. Use your brain power. On opening a box of camphor, its smell spreads all around. Why does this happen? Camphor is a substance that shows sublimation. Therefore, it changes from solid to gaseous form and the smell spreads all around the room as soon as its box is opened. So students, I hope you all understood first part of chapter number 5. Soon we will meet with next part of this chapter. Thank you for watching this video.